Now I will start our video presentation. YAHAYA is Malaysian low-cost airline that operates scheduled domestic and international flight to over 165 destinations in 25 countries. The airline was founded in 1993 by Tony Fernandez and started operation in 1996. It is headquartered in Kuala Lumpur, Malaysia, and has a secondary hub in several other cities. YAHAYA offers a range of flight service including economy, premium flight, and premium flight back option. It also provides in-flight entertainment option and onboard service like duty-free, shopping, and snack.
Introduction for SHA-256. SHA-256 is a cryptographic hash function used to generate a fixed size output in the form of a unique message digits. It takes as input a message of any length and produce a 256 bits hash value. The SHA-256 algorithm is widely used in various security applications, including digital signatures, message authentication, and password storage. How SHA-256 works? Firstly, message padding. The message is first padded to ensure that it's a multiple of 512 bits in length. Secondly, initial hash value. The SHA-256 algorithm begins with an initial hash value, which is a fixed set of 8 32-bit words specified in the standard. Introduction for RSA. RSA is a public key cryptographic algorithm used for secure data transmission and authentication. RSA encryption involves the use of public key and a private key, which are mathematically related but cannot be derived from each other. The public key is used for encrypting data, while the private key is used for decrypting the data. How RSA works? Firstly, key generation. The RSA algorithm involves generating a public key and private key. Second, encryption. To encrypt a message, the sender uses the recipient's public key to transform the message into an intelligible form that can only be read by the recipient. Thirdly, decryption. To decrypt the message, the recipient uses their private key to transform the message back into its original form.
Okay, now we go to what application of SHA algorithm. So the first is data integrity, which is a SHA-256 is primarily used to ensure data integrity, and the second is password hashing, which is SHA-256 is commonly employed for securely strong password. Okay, now we have two others is a digital signature and the file integrity checking. Okay, this is a workflow of hashing 256 operation. So this is a flow chart. What is step is the collect the data message, and then we need to pad the message to ensure it has a specific length requirement for processing, and then we need to initialize the hash value, and then we need to divide the pad message into the block, and then the process each block, and then we need to once all block have been processed, output the hash value. Alright. Okay, this is a more detail of the step. The first step is appending bits. So processing the input message to make it compatible with the hash function. So we have the two, and the first is padding bits, which is the function is add some extra bits to message such the length is exactly 64 bits short of a multiple of 512. And then the second is padding length, and the function is you can add 64 bits of data now to make the final plain text a multiple of 512, right? Okay, now we go to step 2. What the step is a buffer initialization. So we need to initialize the default value for 8 buffer to be used in the round as follow, such as the picture, right? Okay, now we go to step 3 is a compression function. The entire message get broken down into multiple blocks of 512 bit each. It put each block through 64 round of operation with the output of each block serving as the input for the following block. The entire process is as follow, like the picture, right? Okay, this is a step in RSA, encryption and decryption. So this is a flowchart how it works, and I will explain more the next slide, right? Okay, for encryption, we have 4 steps. And the first step is choose a plain text message to encrypt. The second step is convert the plain text message into its numbering form. And the third step is apply the RSA encryption algorithm. And then the fourth step is generate the cheaper text, which represent the encrypt message. Okay, for the decryption step, we have a 4 step. So the first step is receive the cheaper text. And then the second, apply the RSA decryption algorithm. And step 3 is convert the resulting numbering form back to plain text. And the fourth is obtain the original plain text message.
Now we go to advantage SHA-256. The first one is strong cryptography hash function. SHA-256 is a widely used cryptographic hash function that generates a fixed size unique output hash for any given input data. This ensures that any data sent from the AHMAD website is secure and cannot be tampered with during transmission. The second one is resistant to attacks. SHA-256 is highly resistant to collision and pre-match attack, making it difficult for attacker to find the same hash output. This ensures that the data sent from AHMAD website is protected from unauthorized access and tampering. Now I will talk about advantage RSA. So the first one is strong security. RSA encryption use complex mathematical algorithm to secure data transmission, making it difficult for attackers to break. This ensures the data transmitted through the AHMAD website is secure and protected from unauthorized access. The second one is authentication. RSA encryption provides a way to authenticate the sender of a message or data using digital signature. A digital signature is created using the sender's private key, which can be verified using the sender public key.
Here are 3 disadvantages of SHA-256. The first one is length extension attacks. One potential vulnerability of SHA-256 is that it is vulnerable to length extension attacks. This type of attacks allows an attacker to construct a new message that produces the same hash value as an existing message without actually knowing the original message. The second one is limited collision resistance. While SHA-256 is generally considered to be a secure hash function, it is not completely collision resistant. This means that it is possible, although unlikely, for 2 different messages to produce the same hash value. Alright, disadvantage of RSA. The first one is key management complexity. As an asymmetric encryption algorithm, RSA requires the careful management of both public and private keys. This can be complex and time-consuming, particularly for large-scale systems like IRCL website. The second one is vulnerability to side channel attacks. RSA is vulnerable to side channel attacks, where an attacker can use information about the system physical characteristics such as power consumption to recover the private key.